Welcome to our podcast, where we delve into the minds of visionaries and experts, bringing you conversations that inspire and illuminate. I'm Satwik Nath, and today we have a truly exceptional guest with us. Joining us is Dr. Andreas Bueckle, a luminary in the world of virtual reality and augmented reality. Dr. Bueckle is not only an expert in these cutting-edge technologies, but also a dedicated educator, shaping the next generation of visualization experts. Dr. Buechel is a research lead in the Cyberinfrastructure for Network Sciences for the Network Science Center at the Luddy School of Informatics, Computing and Engineering at Indiana University, and his work extends to the fascinating intersection of technology and education. Today, we're diving deep into the realms of AR and VR, exploring their transformative potential and the exciting developments on the horizon. Without further ado, Dr. Buechel, over to you.
Thank you so much, Satwik, for having me on the podcast. It's really an honor to be here today. You described me with quite a few words. I think the number one label I have for myself is I'm a tinkerer. I love learning new things. I love throwing things against the wall to see if they stick. And I love developing things. A big part of doing VR is to trust and like get involved with new technology that really isn't very mainstream yet. We've been kind of waiting for VR to make the big breakthrough for many years. And
Yeah.
there's a lot of pretty amazing VR hardware out there now that is, affordable,
Yeah.
at consumer grade, right?
Mm-hmm.
But VR is still considered mostly an entertainment thing. It's mostly still in gaming. There are some applications outside of gaming that are big, and there's obvious use cases for it. But you will most corporate offices in the world will not have any kind of VR headsets, even though that was kind of one of the usages that was envisioned for it during the pandemic, for example. Um, Most educational spaces maybe have a VR lab if they're well funded, but it's not a normal tool. Like in many classrooms all across America, you will find iPads, for example, or tablets or smartphones or computers. You will probably not find VR headsets there.
Yeah,
So
that's
it is
true.
still a very developmental technology. Do you guys have VR headsets in your school?
No, we don't have VR headsets. I haven't really ever seen VR headsets being used other than gaming. There was this one time I was working at a lab, however, where they had used VR headsets, and in that lab they used it for like helping people who are unable to move parts of their body to like maybe like help and try to get them back by like adjusting the how much the each movement was in VR compared to how much they moved it in their hands. So that's one of the uses that I've seen of VR.
Yeah. Yeah, there's this kind of usage space where you can use VR to give somebody superpowers.
Hmm.
For example, to control a machine that is on a different planet. I saw a really cool demo a few years ago where somebody was controlling a virtual version of a Mars rover, and then with a 5-second delay, the actual rover on Mars would do the same movements. So you could basically plan the movement in VR and then execute it, and then the rover would actually do them. So
Hmm.
extending your body into a different realm where you couldn't normally control. Likewise, giving you superpowers that maybe your body has lost or that no human body has, like um, entering worlds that do not really exist or looking at data in a way that is not normally supported by any of our senses. So that's where VR truly shines. I've seen a lot of really cool VR applications for therapy, such as to treat PTSD, for example, in veterans.
Hmm.
And these to me are absolutely the natural use cases for VR that are really hard to replicate with any other technology. Um, my work is in the realm of data visualization and data analytics, where
Hmm.
VR has very particular benefits, but it also comes with design challenges. And I want to talk a little bit about these today.
Okay.
But yes, so you have used a VR headset before, I assume?
Yeah, I've used a couple of VR headsets, but not for much other than gaming.
Yeah, yeah. And even for gaming, like the game has to be worth it. Like I have tried a few games in VR.
Hmm.
The problem oftentimes is, the last thing you want to do after a long day of work when you want to game for an hour is you don't want to have to set up an entire VR thing. Um, you just want to fire something up, use a keyboard and mouse, and it works. So the game has to be worth it.
Yeah,
And I
that's
think
true.
there are some pretty. I, mean, I don't know if you've played Super Hot VR or Half-Life Alyx.
No. I think the only game I've played is Minecraft because,
Yeah.
well, my friend has it on his VR headset, and that's like
Yeah.
the only one I've used. So yeah.
I'm actually curious, like when you're in Minecraft in VR, a lot of Minecraft from what I've seen is like inventory management. Like you got your
Yeah.
materials, you gotta build stuff. How does that work in VR?
In VR, so something interesting is there's like multiple ways to punch the block. Either you can physically like actually punch it, or there's a button on one of the sticks where if you press, it'll break the block normally. And then like opening inventory and managing stuff like that is also like opening blocks or clicking buttons, and that will open up the inventory. And then you can like click on things with the trigger on one of the sticks and move it and drag it.
Okay.
Yeah,
That sounds like a workout. I mean,
it is.
it's a lot of movement.
Yeah. But like there are buttons which like reduce the movement. So if
Yeah.
you don't really want to work out, you can just use those buttons.
Okay. Because like in a normal video game, there's a lot of things like interactions with the world that are just mapped to a button. Say you play a game like The Witcher.
Mm-hmm.
You go to a house, you open a door. Normally, all you do is you press a button, and then a lot of really complicated things happen. The door has to change its state, it has to swing open, your
Mm-hmm.
character has to walk through. And it's a lot of stuff happening under the hood. But if you're in VR, suddenly all of these movements that are normally executed by, just one button press, suddenly you have to extend your arm, you have to hold on to the knob, you have to turn it, you have to push. Suddenly the interaction becomes a lot more minute. And so then even like, the simplest interactions suddenly become a lot more involved.
Mm-hmm. That's true.
Personally, I love that about VR. It feels like you are more in control, and I guess that's where the whole immersion angle also comes in.
Mm-hmm.
But certain games are suddenly pretty rough to play in VR.
Yeah.
Um, have you played Skyrim before?
No, I've never played Skyrim.
Okay, I've played maybe 5 hours of it,
Uh-huh.
and my brother has Skyrim VR, so
Uh-huh.
I tried it, and the thing is like in Skyrim you have combat, right?
Yeah.
With like with shield and sword,
Mm-hmm.
and you would think that if you're in VR with a shield and sword that you could do really awesome, movie-like movements and battles, but actually all you end up doing is you stand there and you crouch and you just try to hit the opponent's legs.
Mm-hmm.
It's very awkward. So with VR, it's really never what you expect, which is kind of the
Yeah,
charm of
that's
it, I
true.
feel like.
Yeah, so why don't you tell us a little bit about what your job is, what you do?
All right. So as I said, as you said, I'm the research lead in the Cyberinfrastructure for Network Science Center. We are a center in the Department of Intelligent Systems Engineering here at IU Bloomington. We do data analysis, data visualization, and atlas making. And so what I'm going to talk to you today about is the Human Reference Atlas in virtual reality. And so I lead I'm the research lead here, so I'm in charge of handling publications,
Mm-hmm.
tracking deadlines, organizing research talks, and I also have my own research agenda, again, revolving around data visualization and virtual reality. I got my PhD from IU in information science, and yeah, I'm really interested in tinkering, that
Mm-hmm.
involves learning new software, learning new technology, and with VR also learning new hardware.
Yeah.
We are using the Unity game engine to
Mm-hmm.
create three-dimensional environments, read in data, visualize it, collect user data, and then run human subject studies with that also. So we use the same tools that video game developers use. Now, I wouldn't consider myself a gamer. I just don't have
Mm-hmm.
time for it. But we use the same tools. And of course, just like video games, we create 3D worlds. Now, what people do in there and what the incentive structures are completely different, but the building blocks are the same.
Mm-hmm.
So what you will see today, these are not AAA graphics, but again, it comes from the same tool.
Yeah.
All right. All right. So with that, I want to briefly talk about what exactly virtual reality is. And you also mentioned augmented reality earlier.
Yeah.
Because I'm an academic, I like to come with, more academic descriptions. But this one is actually pretty accessible and it describes it pretty well. So
Okay.
this is from a 1994 paper. So this is old. This is like almost 30 years old.
Uh-huh.
from Milgram and Kishino, who proposed the so-called virtual reality continuum. And the idea here is that we can posit all of these technologies along an axis that goes from a real environment to a virtual environment. So in a real environment, this is a real environment where there's no technology at all. So this is basically the physical world that does not have any kind of augmentation. This is what you would see without using any technology. And then on the other side is a completely virtual environment where everything that you can see all across the scene is modeled. In that you have access to the physics, the lighting. You actually need like a whole separate engine just to handle the physics and the lighting, because you're basically creating a world from nothing. Okay, it's like creatio ex nihilo, as they say in Latin. It's like creation of nothing, a whole world out of nothing. This also means that we have full control over everything. That's virtual reality. So in virtual reality, like with this headset here, the physical world gets basically shut out on the visual anyway. And then suddenly then you are fully immersed in the virtual world, where you have full control over every aspect of it. But then in the middle of it is the huge realm of mixed reality, where parts of the scene are physical and parts are augmented or virtual. So this is Pokemon Go, of course. And
Yeah.
the Pokemon Go was ridiculously successful for multiple reasons, but one of them is that augmented reality is a lot more accessible than virtual reality. For virtual reality, at least for the kind that I'm doing, you need a head-mounted device, and also it shuts out the entirety of the physical world. Augmented reality, on the other hand, allows you to keep the physical world present, and you can basically use the entire existing physical world and just kind of sprinkle your content on top of it. And that's exactly what Pokemon Go did. Of course, this is more on the realm of augmented reality, where reality is mostly still physical, but we just add a little bit on top that is virtual. On the other hand, we have a thing called augmented virtuality, and this is a term that did not survive the 90s. Augmented virtuality was, where you have the majority of the stuff in your scene is virtual, but you have maybe a human actor in it, or a little bit of content that's physical. Now, if you think about a movie like Avatar or most Marvel movies, those are basically fully CGI, except you have some humans sprinkled in there with green screens. And that is essentially what augmented virtuality is. It's just we don't call it that anymore. But the concept, like the idea survived, but the term didn't. And so Milgram and Kishino said that we can further define these along 3 more axes. And I really only want to talk about this one, because this is a really interesting one to me. So if the world is fully real, then the world is unmodeled. It means that we have no access to the world. Like, we cannot write a computer code to interact with it without having a model of it first. On the other hand, in a virtual environment, the world is completely modeled. So we have access to it on a computational level for everything that is created in that world. I don't know if have you ever seen The Matrix?
Yeah, I've watched The Matrix.
Yeah, so it's one of my favorite movies.
Yeah,
But
it's one of my favorite movies as well.
yeah, I mean, it is just excellent.
Yeah.
So the base start in the Matrix is that the machines have full access to the entirety of the modeled world, which of course the humans think is the physical world, but in fact it is the virtual world. And
Yeah.
it gives the machines full control over the humans because they control the entire world, because to them it's modeled. And then, of course, there's a huge area in the middle where the world is partially modeled. So, for example, here for an application like Pokemon Go to run, the phone needs to have a partial model of the environment, not a full model, it's not needed, just some kind of spatial anchoring, like, for example, knowing where the floor is or where GPS-wise on the planet the user is. And these are things that with modern smartphones you can get rather easily, which is why smartphones are such an amazing device for augmented reality. And probably the best augmented reality device that we have. However, of course, this is the Meta Quest 3. The Meta Quest 3 has video pass-through. There's a series of cameras mounted on the outside that gives you a colored, high-resolution video throughput that you could also use for augmented reality. And more, this might be the future of these head-mounted devices, is using them for mixed or augmented reality. And then, for these kind of gaming, educational, fully VR environments only in certain cases. So I think the most promising way forward for AR are actually these headsets that can do both. Have you ever worn one of those?
Not that specific model, but I have worn headsets before.
Yeah, so if you use the Meta Quest 2, which is the one that came out before then, it had black and white and kind of low res environment. It was enough to allow you to walk through your apartment and not stumble into things. But with this, you could actually represent the world around you and then augment it with content. It's actually a huge step forward. And if we give that a few more years, then and these headsets become smaller and hopefully more acceptable to be worn in public, it's gonna be a game changer if that happens. If you do research like me, then we don't build our own hardware. We use off the shelf, and we use stuff that is commercially available and usually consumer grade. And so of course you kind of limit it to what the market gives you, but it is very promising. And obviously Meta has seen that there is a use case for this. So what I mean by VR in this talk, then, just to clarify, are these kinds of headsets that have a headpiece and controllers. And there are two broad flavors of VR. This one, for example, the HTC Vive, which is one of the devices that I also have in my office. It's a little bit older. The HTC Vive comes with a headset that has to be plugged into a link box, and then the link box goes to a computer that's actually running the application and rendering all of the graphics and to power here. And then there are tracking stations in the room that spray the room with infrared light that allows the headset to track itself. And this is also how the controllers are being tracked. So this is called tethered VR. The advantage of this is that it's a lot more high end. Like the graphics that you can pipe into the headset are much better because you're running it from a high end PC. The disadvantage is it is not mobile. I actually had to lug it around quite a bit for my dissertation, and it's a full suitcase full of equipment. And you need a really expensive machine that can actually render these graphics. Now, on the other hand, we have standalone devices such as the Oculus Quest or the Meta Quest. These are completely self-contained, and everything that you need for it you can see here, and it all fits into a neat little carrying pouch, and you can carry that in your carry-on luggage when you travel. And these things are only going to get smaller, I think, as time progresses. And again, contrast that with what you see there in the background. This is a tracking station for the Valve Index, which is kind of a more advanced model of the HTC Vive. And suddenly you need tripods and tracking stations, and then need power, and it's a whole thing all of a sudden. So these things really have greatly changed how we also do research about virtual reality, and it's also cheaper, of course.
Yes.
Now, one of the reasons that I find so cool about VR as a medium is the input devices. So the mouse is a 60-year-old input device. The mouse was invented in the 1950s, 1960s by Douglas Engelbart, who was a research scientist out in California. And I don't know, have you ever heard about the mother of all demos?
No, I haven't.
This was a demo that Doug Engelbart gave in 1968, where he demonstrated essentially the first functional personal computer. At the time, computers were the size of this office here. And interacting with them, the graphical user interfaces were still in their infancy. And Engelbart put together the first idea of what we would consider today a personal computer, where somebody sits somewhere with a monitor and a mouse, which he had to invent in the progress, and a keyboard. And he was editing, I think it was a shopping list. And then at the same time, his assistant was also using a similar device, and they were editing it together. They were basically doing Google Docs 20 years before the World Wide Web was even invented. And our professor back in grad school showed this to us, and I've been fascinated by this thought ever since, that this device, think about how ridiculous this device actually is and how old it is, and we still use it all the time, right?
Yeah.
And so you have this device which gives you 3 buttons and an XY position. And then suddenly with VR, you have a multidimensional input tool. So in VR, we have 2 controllers. So we have 2 hands, so we have 2 controllers. And then we have a series of inputs. We have a joystick, which you would have on a video game controller too. You have buttons, and you can see, these mirror what you would have on an Xbox or a PlayStation controller, except you can separate them from each other, and you can also rotate them. So you have three-dimensional position and three-dimensional rotation, which you don't have on a game, on a Xbox controller. And then you have all of these buttons. Now, this is from the MetaQuest. This is the Oculus Touch 2. This is the version for the 3. But it's very similar buttons. So the ability for the user to provide input to the application are just hugely different. Of course, this makes it more challenging. Many people, when they hold a VR controller for the first time, have no idea what to do with it because they have never interacted with this kind of stuff before. All right. So there is this vision then in medicine and healthcare to use augmented and virtual reality for healthcare or for patient applications, for doing data analysis. And oftentimes what you will see are these kinds of images where this is a stock image I found in this news article here. So this is an operating room, it looks like, and you have these two people, they're either nurses or surgeons, and they're looking at what looks like a 3D model of a brain. And it looks kind of cool, but of course it is completely unrealistic. We do not have, so for one, none of them is wearing a headset. We do not have holographic technology yet at that level. And then also the question is, well, what exactly would they be doing in this situation? Presumably they're planning some kind of surgery, but normally this planning would hopefully happen outside of the operating room before the patient is there and sedated. And then also, if you look closely, it's kind of uncertain what they are even looking at. Like there are no annotations on it. There are no guiding markers. There's nothing really there. And so this is oftentimes where, this is a vision that somebody drew up, but what would this actually look like if it were deployed to a real situation? So in reality, many VR and AR applications exist, but they are purely for learning anatomy and physiology. So you see two examples here. This is from an application where you can dissect, or like you can like peel away the layers of muscles in the human body. Here you have something that's slightly more photorealistic, although I mean this is still pretty like simple graphics, where you can see a series of interconnected systems. So you can see the muscular system, you can see the vascular system here. Presumably there's nerve vasculature or lymph vasculature in there as well. You can take out these organs. It's a little more interactive. And so the models vary in detail from photorealistic and detailed to a little more low level. But none of these applications display any kind of actual patient data. It's just modeled based on one particular patient or based on a model patient. So the question then is, well, where's the data? And this is where my kind of work comes in. So again, part of my work is in data visualization. And so this is a quote from a German computer scientist, Daniel Keim, from 2001, where he said, "Visual data exploration seeks to integrate humans in the data exploration process, applying their perceptual abilities. The basic idea is to present the data in some visual form, allowing the analyst to interact with it." So what this quote speaks to is the symbiosis of computers and humans that is only possible with visualizations. Because visualization is for humans only. A machine does not need a visualization of the data set to meaningfully interact with it. And so, of course, many formalizations have been made for making, interpreting, and teaching visualization. You can see examples here. This is from a paper that we published last year or the year before, where we have a user in VR interacting with a data set. This is actually a visualization of this user's own movement while they were doing a task before. And then this is some secondary data. This is the same data, but visualized in 2D. So this is a bird's eye perspective. You can see these people actually walking around here. And then we have this hex bin visualization of where they were for most of the time. So it's very rich interaction data that comes out of these VR environments. And so I work in a team that specializes in data visualization literacy, or the ability to read and make data visualizations. And so this is from a paper that we published in 2019 that lists how we can use color and different reference systems and these different geometric symbols and forms and textures to create meaning in a grammar of graphics, essentially. And yeah, feel free to peruse that paper. I think it's fairly straightforward and straightforward to read.
Okay.
Now, the problem, of course, is that data visualization in VR brings its own unique perceptual challenges. So 2D, generally speaking, is simplicity. There's a reason why bar graphs or line graphs are so popular, because they are easy to read, they're easy to print, And you can condense a lot of valuable information into very small screen space. Now, VR, however, is three-dimensional by nature. It's kind of the whole point of VR, to give the user a three-dimensional scene. But with that comes some perceptual challenges. So one is the depth cue. So occlusion happens when two items are in front of somebody, in front of a camera or in front of an eye, and they intersect with each other. So for example, if I show you my hand, I occlude myself. This is a perceptual cue to you that I am farther away than my hand. It's an important thing for a living being to understand that, because it can help you understand potential dangers. So really, Tamara Mansur in her book Visualization Analysis and Design mentions, in reference to Ware's book, that we do not really experience the world in 3 dimensions. We experience the world in 2.05 dimensions, because at any given moment you have the full breadth and the full height of your view, but depth is severely limited because there's only so far you can see, and again because there's occlusion happening, and so you will not see beyond something that occludes your view. And you can see an example here. This is from a network visualization I made last year. This is a network of actors in a social media network. It becomes hard to see some of these nodes because they are just obstructed by other nodes coming in. And that is a big problem in visualizations. So how do you make sure that the entirety of the scene is visible to the user? You have to give the user the ability to actually walk around in VR. And then the other problem, that's also a big one, is the foreshortening effect. So oftentimes in data visualization, we use size as an indicator for a quantity. So, for example, let's say you have a scatter graph where a dot is a certain data entity, and one dot is smaller than another one. It means it has less of a quantity than the larger one. It's a very simple visual encoding that's extremely powerful, because we are able to distinguish relatively minute changes in size. But in VR, that becomes a problem, because consider my hands. They're the same size approximately, and they're at a certain distance from you. But if I move my left hand farther back, it's going to start to appear smaller. That's the foreshortening effect. So if you want to use then in VR size as a graphic variable to encode a quantity, it appears as though this hand is smaller when it isn't. It's just the 3D foreshortening effect. So that's another problem that you have to overcome when you want to do data visualization in VR. And in general, visualization experts recommend to not use 3D as a purely aesthetic choice, because it introduces confusion. And it introduces potentially all of these occlusion and foreshortening issues as well. So these are perceptual issues that we have to deal with.
Okay.
Yes, so let me jump ahead real quick so I can show you actually something in VR. Let's see. What I would like to show you now is the Human Reference Atlas. So we talked about data visualization. We talked about virtual reality as a medium, about its application, about the hardware. I would now like to talk about a concrete use case where we are using VR to enable an immersive view into something that is 3D and that lends itself to this kind of visualization. So the Human Reference Atlas is an atlas that we are putting together here. It is funded by a variety of NIH-backed efforts. And it defines the 3D space and shape of anatomical structures in the human body, and as well, and the cell types that you would normally find in these anatomical structures. So for example, the left ventricle of your heart, or the renal pyramids of your kidney, or the sigmoid colon of your large intestine. So we map which cell types are normally found in them, and then we also map which biomarkers are normally used to characterize these cell types. So the Human Reference Atlas also defines how new data sets can be mapped into this Human Reference Atlas. And it provides what's called linked open data. So this means this is data you don't hit any paywalls anywhere. There are no emails you have to write to someone to get access to the data. all of the IRIs resolve if you put them into a web browser, or if you make a web request. And generally, there's three types of data. There's spatial, so it defines, for example, the position of a tissue block or the size of an organ. The biological structure, so for example, the left ventricle is characterized by 8 different cell types that are in turn characterized by 100 different biomarkers. And then also specimen and clinical. So for example, for the heart, we have 5 tissue donations, and they're made by 5 humans. 3 of them are female, 2 are male, etc. And then the human reference address is authoritative. So it means it was built based on expert agreement, and it is validated by data. It is computable. It means that it's not just an image in a book somewhere, but it's something that you can run API queries against, and that can be displayed in user interfaces, such as the VR user interface I'm going to show you later. It is, again, published as LOD. So it is connected to existing ontologies. That's like, organized knowledge domains.
Yeah.
It is also open in that anyone can use it, and it's not paywalled in any way. And it is continuously evolving, and as in we make 2 annual releases and release new HRA versions. The next one actually drops next week. That's HRA 2.0. That's a pretty big release. Now, importantly for VR, the recent version of the HRA, which is 1.4, again, next week we're releasing 2.0. We have 65 anatomically correct 3D reference objects. So these are 3D organs. Think kidney, but we actually have 4 kidneys, 2 male, 2 female. We have colon, large intestine, small intestine. We currently have 2 reference bodies, a female and a male body, and we might build more in the future. But as you can imagine, it is a lot of work to make even one organ. And so this is the collection that we have. This is why we only have 2 bodies so far. We also have 31 so-called anatomical structure, cell types, and biomarker tables. This sounds horrible. Think of this as a big table that has a list of all of the anatomical structures for an organ, such as, again, the left ventricle, the right ventricle of the heart, the septum. And then for each of them, it has a row for the cell type. So for each pairing of cell type and anatomical structure, it has a row. And then there's yet another column that captures the biomarker. So each row is a unique combination of biomarker, cell type, and anatomical structure. And these are authored by experts. We do not have expertise in any particular organ. We are system integrators and information scientists. So we work with experts to author these tables for us, and then we process them, we validate them, and then we put them out into the world as part of an HRA release. And importantly, and this is why my work comes in, we create tools to explore, use, author, and review the Human Reference Atlas. So there are 4 that are of most relevance to what we're talking about today. The registration user interface, which is an interface that allows you to define one particular tissue block in one particular organ. So if you are a center that has a kidney donation, for example, and they cut out a piece from it, you can use the registration user interface to indicate where in the organ that it came from. The second one is the sys interface. That's the exploration user interface. This is where you can see all of the tissue blocks from all of the organs. So if you register something in the registration user interface and it goes through the processing pipeline, it will appear in here, and this is fully 3D. Okay. Then we have the ASCT+B reporter. This is a tool that visualizes ASCT+B tables. And you can see here that this is kind of let me see if I can zoom in here. Here we go. You can see that this is kind of a tree structure. So this is actually a table, but it is visualized as a tree. So if you start here and you follow like one line all the way to the end, that is one row in the table. So this is a tool that we designed to allow people to visualize the anatomical structure, cell types, and biomarker table, see if there are any errors, and then refine as needed. I'm a big fan of network visualizations, and this is a really beautiful tree visualization, which is a network. And I'm a very big fan of this one. And then finally, we have the Human Reference Atlas Organ Gallery. That's a virtual reality application. I will demonstrate that here in Unity in a second, where we have the 2 humans. You can see that these are the same humans, except we had to make some aesthetic changes to the lightings and the materials, which is why they look slightly different, but it is the same data. We get the data from the same thing, except here it's shown in a web browser rendered using DeckGL, and here it is shown in a virtual reality environment made with Unity. And then you can see we added some glowing logos here for all of the funded efforts that were part of it. And here you can see here in the middle, here you can see the humans, and then here you have a keyboard that allows you to inspect organs in more detail. And maybe now would be a good time to actually go over into VR and demonstrate that bit. So this is Unity 3D. Unity is a video game engine that allows you to create 3D content, like 3D real-time content. And we use it to develop the organ gallery. So I'm going to play mode here. And then what will happen is that it takes a second, and then it has to make an API call, and then we'll see some organs appear. So a note about practicalities. When you develop for VR, a lot of time can sometimes be spent taking your headset off, putting it on, taking it off, putting it off. So the way we do VR development on our team is we use a thing called a device simulator. So we can pretend like we're in VR inside of the Unity runtime, but we're actually using our keyboard and mouse. So you can see that here. As I move around the scene, I'm acting as if I was in VR. So you can see in front of me, I have my controllers, my right controller and my left controller. And I'm basically acting as if I was in VR. I'm just using my keyboard and mouse. This speeds up development. This is great for testing basic interactions. But of course, once you actually want to test the feel and the gameplay, you have to try test it in VR. But for where we are right now, this simulator is fine. So in the middle, we have the two humans. I can actually fly here as well. So here they are. We got the female on the right and the male on the left. What you see here, these lines in the back, I'm currently I'm in a development sprint where I try to implement a bunch of new features, and this is something that we're implementing where well, it's just not done yet, which is why you have these kind of artifacts in there. But I love to show work in progress. Looking at the male here, for example, this is the lung in here. I can actually dive in here a little more and can see how detailed the organ is. Now, this will look different in VR. It's going to look a little more transparent. This is just showing here in the middle. You can also see, by the way, if we look in here, you can see the tissue blocks. So these are each of these is an actual tissue registration that belongs to one actual, or actually multiple, human donor. So there's actual human data behind each of these cubes. And the beauty is each of these cubes is annotated with an ID. And when we call this ID, because it's an IRI, so if you make an API call to it, you get data back. So you know what? Let's actually just test it out. I'm going to show you that in a second. So first, let's say a user wants to inspect an organ in more detail. Then they can press a button on this organ keyboard. So for example, let's say I want to look at the heart. So you can see up here, we have this white light box. Click on the heart, turn screen, and now boom, here's the heart. And so now the user can look at the heart, can inspect the terminal angles. We added this kind of hoop here, and if you can see that, there's a loop here that you can probably already grab. No, not yet. So this is a loop that you can grab with your right hand, and then you can move the organ. And that's, of course, something that you really have to test out in VR to really appreciate just what it allows you to do. You have to imagine many of these people that we make this application for, they do research on kidney images and cell type populations and imaging, but they never actually get to hold the data in their hand. What this application allows you to do is it allows you to literally grab the organ, scale it up, move inside, and understand the anatomy and physiology and how it relates to the data that is being visualized. But where it becomes truly interesting for us is, let me exit out of this real quick. I want to show you now what's happening behind the scenes here.
Okay.
So we are loading our scene. And this is the scene view. Think of this as the staging area. Here we can move around in 3D. We can grab objects. We can move them. Of course, it looks pretty freaky when we do that. So here's where we can actually assemble our 3D scene. So I want to go and I want to zoom in on one of these tissue blocks. So let's, for example, try and take this one, maybe this one. So here is a tissue block. And as you can see here, we have a tissue block component for it, which is here we go. So this is our tissue block data script, and you can see that it has a so-called entity ID. And if you look at this closely, you will see that this is a URL. So this is something that we can put into a web browser. Now, this is not the best example, however, find a different one. Yeah, so this is the entity ID for this particular tissue. This is an actual tissue donation, and this is its entity ID. So currently in the scene, this is all we know. But what we can do then is we can make a web request, and I'm going to bring up a browser here really quick. So what I did is I punched this entity ID in here, and let me actually demonstrate that in Firefox. Because it's going to be looking prettier there. Here we go. So I'm in Firefox. I'm going to punch that in. And then this is the response. So this tissue block has one entity ID, but if you make an API call in VR, we get all of this data back. And this is insane. This is the linked open data that I mentioned earlier. So it tells us who created this tissue block. It was an individual, well, individual here. It tells you the email address. It tells you the particular user ID. This is a Linux timestamp, Unix timestamp. So this is, I think it's milliseconds since January 1st, 1970. So you can then calculate, okay, when was this created? We have, and then we get a ton of data, and all of this for this one tissue block. So what you can do then is you can give the user the ability to click on tissue blocks and then give them this information, you know, as they need it. Think of it as if you play a game and you click on an item and you want information about it, like what its health stats are, what is its damage, what is its name. We're doing the same thing, except we do it with tissue blocks that have actual human data behind it. So I am not a biologist. A lot of the the specific terminology and a lot of the really specific domain knowledge is very foreign to someone like me. But as a system integrator and visualizer, it is my task to work with people that have this expertise and create tools for them that they can then use to advance their own science. And of course, this can also be used to do outreach and to communicate to people outside of science what it is that we are building in these types of scientific consortia. And VR, I think, is a fantastic vessel for that because it has a novelty aspect to it and an interactivity aspect that is just inherently engrossing and that lends itself really good to public outreach. So this is part of the stuff that I'm doing and that kind of keeps me going forward and that gets me interested in getting the word out.
So, how would you say that someone would get into like how the fields that you're working in? Like, how would someone like a student like get into VR, and how would they begin doing something like you are?
Yeah, I would say it is probably very similar to how would you get to making your own video games. You know, there's like two sides to it. There's tools that you use, and then there's the experience that you need to get. So getting the tools, you know, the tools are out there. Most larger game engines have personal licenses that you can use, you know, for school projects or just for your personal time. There's of course the hardware tool, like you know, you need a VR headset, you know, to actually try out what you did. They come at various price points, and I think they have been as affordable as has ever been. Plus, if you are in a high school or if you're in a college that has a virtual reality lab, then you have the hardware there. So that's one thing. That's the tools. The other one is always the experience. And in my what I would recommend when it comes to learning new software or new programming languages is to sit down for 3 or 4 hours and go through materials that are online. I learned most of the stuff I needed to learn for VR from YouTube, because the VR changes so fast that oftentimes these, like, big online courses, they're not fast enough at adapting, but YouTubers are really fast at adapting to the latest version of the XR Interaction Toolkit or the new Unity version. So doing that, sitting down for a couple of hours and learning the basics, and then also just start a project and try to see it through. And it can be super simple. It can be something like, I want that to be a scene with a tree, and I want to be able to walk to that tree. That's already going to teach you so many of the basics that are relevant, like to get an initial set of experience. So the tools and the experience. And there's really no way around, sitting down and like familiarizing yourself with it, just like with everything else.
Yeah. So also, what are some of like the impediments? Like you said that there was like some like there's like you have to deal with like distance and like obstruction. Are there any other impediments that you have to deal with?
Yeah. I would say probably the biggest one is motion sickness. Some people are inherently prone to getting motion sick, even if they sit in a car or if they sit in front of a large TV. And, to a certain degree, there's not much we can do about it. Some people just have that
Yeah.
propensity. But there are design choices that we can make and performance improvements to minimize the risk. So broadly speaking, there's three. Number one is be sure to give the user a horizon, something that they can look to at the horizon. Have you ever been on a cruise or on a ship on the ocean?
Yeah, I've been on a couple of ships, yeah.
Okay. So what is typically recommended to people that tend to get seasick is to stay above deck if possible and focus on the horizon. It
Mm-hmm.
it um it helps your visual system stabilize um and and keep your balance essentially. So that's number one. Number two is to optimize frame rate. So you might be familiar with the concept of frame rate.
Yeah.
It's yeah. So it's important for like the aesthetic appeals of a game or of a VR experience, but it
Mm-hmm.
also minimizes the risk of motion sickness. The one time when I got motion sick myself, I'm lucky I don't have a propensity for it. The one time it happened was um, I made an application. I was trying to do a thing where I was like shooting lasers out of my hand, and
Mm-hmm.
I think I overloaded the I put, maybe there was just too much stuff going on in the scene. The frame rate dropped to about 1 frame a second for 5 seconds,
Uh-huh.
and then that caused the horizon to tilt, and I was motion sick for 2 hours after that. So optimizing frame rate is really important, and it's
Mm-hmm.
generally important. You should always try to hit a certain frame rate. Meta requests 72 for the Meta Quest 2, which is, I mean, this is high. This is a high frame rate to aim for.
Mm-hmm.
Think about how most video games, they try to do 60 frames per second, but they rarely
Yeah.
get there. And now you're running on hardware that is much, much weaker than that.
Mm-hmm.
So that's a design challenge for sure. And the third one is to give the user to darken their peripheral vision. You will see that in some VR experiences where whenever you turn by more than n degrees over X amount of seconds, your peripheral vision will shrink and you will
Mm-hmm.
basically look through a black tunnel. This is another thing that you can do to minimize the risk of motion sickness.
Mm-hmm.
Um, for the one with the horizon and the one with the tunnel, it's called a tunneling vignette. There's easy assets that you can just reuse in your application. The frame rate one really depends on your project and what you are trying to show, what you want to allow the user to do. If you have an application that's in a densely populated city, you're gonna have to optimize like crazy. If you have something that is basically an empty room, it's gonna be much easier. You can do
Mm-hmm.
things like pre-bake lighting to avoid real-time lighting. There's a lot of tricks you can do, and they all play a role in game development as well. And you can find a lot of resources online, given for what kind of experience you want to craft, that allow you to optimize for these things.
Mm-hmm. So, where do you see this technology going into the future? Like, do you see that it would be more commonly used? Like, would it be used in like healthcare and like would like you said that you thought that in the beginning you said that if it would be acceptable for people to walk around with this technology, then it could be more commonly used. So, do you think that in the future it would be acceptable?
it's really hard to make predictions. You know, it's really easy to sound totally stupid in 10 years. Um,
Mhm.
I do think that we already have technology on our hand that we use all the time
Yeah.
that is capable of amazing augmented reality, of amazing augmented experiences. I will say that this headset is extremely popular. I mean, there's millions
Mhm.
of them sold.
Yeah.
And they do have the capacity to do a wide variety of techniques. As I said earlier, it can do VR, it can do AR. So I think there is an ongoing market for these kinds of headsets that you wear in particular situations indoors, such as for gaming or for watching movies or
Mm-hmm.
for watching something while doing chores. Like the other day, I think I was cooking and I had my headset on and I was watching YouTube at the same time. You know, you can do the same thing with your phone, but you know, the second you turn away, you want to get something, the headset just follows you, like it displays it
Yeah.
for you. Likewise, in the headset, for example, you can watch, if you want to watch a movie on a streaming platform, you know, you can do that in VR, but then suddenly you sit in like a mansion on a nice big couch with a big display in front of you.
Yeah.
So I think there will be an ongoing market for this kind of usage where you're kind of in a confined home environment, or if like me, if you work in a research lab.
Mm-hmm.
Then there is the phone for like a more mobile use that's already there. And then, you know, maybe there's a third type of device in the future that is a headset, but it's smaller. It's basically like the glasses that you're wearing.
Yeah.
Um, or contact lenses. You know, 10 years ago, Google published the Google Glass and it didn't go anywhere because I think it
Mm-hmm.
was too early for the tech. The use cases were not there. And I think there was just a bias against this idea that somebody could just film you without your consent. But now we are so like recordings of our everyday actions are so omnipresent now thanks to social media platforms that I think this hurdle has fallen away. But it's up to like, you know, companies to actually fill in that gap and develop this kind of hardware. Maybe we will have devices like this in the next couple of years, maybe not. There are already
Mm-hmm.
use cases you are asking about healthcare. There are already use cases where VR is used for therapy. Again, I mentioned earlier PTSD
Yeah.
treatments, exposure behavior therapy, you know, where you expose people to phobias that they have.
Mm-hmm.
So these things already exist. I don't know how large scale they are, but the technology is there, the software is there, um, the research is presumably there too, but these are still niche things, I would say. I think it'll be quite a while before we will see people on the streets out with their VR, AR devices doing content there. I think the closest we had was Pokemon Go,
Yeah.
and yeah,
So Pokemon Go did have some problems though. Like people oftentimes they like walked off like the edge of like the road or they walked onto the road and they got hit by cars. What do you think like do you think that VR will like help against that? Because like in VR, virtual reality, there's like less real world, but augmented reality, you actually have ability to see the real world, but there are still people who are like walking into these dangerous areas.
yeah. I mean, it even happens when people just use that text app, right? Like if I have iMessage open and I walk across the street, then it's basically you have the same problem. I have seen instances where, you know, people had like a camera feed running in the back of their text messaging app so that they would at least still see the street.
Mm-hmm.
Um, if you had the peripheral sensors, you could probably detect, or a camera on the side, you could probably detect if a car is approaching. These things are possible, but with the cameras that are currently in there, I don't really know if it is. Um, Ultimately, you know, there's a level of personal responsibility that you have to have during media usage. I think it's very important to teach media usage from an early age, just
Mm-hmm.
because there is no way around using smartphones anymore or the internet. I mean, think about how many functions you have to do as a citizen that would not work without the internet.
Mm-hmm.
So I think media education is going to be especially important. With regards to AR and VR technologies, um, yeah, it's I remember seeing the news articles like when Pokemon Go got really big and like people battling over Pokemons and whatnot. And yeah, to a certain degree, you know, that's just what new technologies bring with them. It takes us a while to learn to use them, like norms have to be formed and ethos has to be formed over time. And this is a consensus finding process that, that will take time.
Yeah, that's true. Anyways, what advice would you have for students who want to learn and apply to this new technology?
Yeah. So I would recommend to search out opportunities for virtual reality labs that might be available at your institution. I would recommend if you have the access to it at all to get one of these devices and to understand if this is something that you want to do work with. There are certain types of media that there is no way around. Like you cannot, like most jobs you cannot do without sitting at a computer or interacting with a monitor or a keyboard or a mouse in some way. It's just part of it for most white collar jobs, right?
Yeah.
For VR, you have to identify, is this something that I can see myself doing? Does this interest me to a level where like I want to devote significant amounts of time to it? Best way to do that is to get a VR headset, play a bunch of games, and understand, is this something that fascinates me? It is, again, still relatively new technology, and nobody really knows where it's going to go. So I would really recommend to try it out, to give it like a fair chance. And then, of course, to not be afraid to learn the tools necessary. And I mean, that will probably involve programming. In Unity's case, it's C# that has to be programmed.
Yeah.
To learn the basics of 3D models and like volumetric 3D models, like what is an FBX file? How does lighting work? What kind of software exists out there that I can use to make simple 3D models? And the nice thing is that this stuff can be very fun because it's very visual and it's very interactive. So that's like the third bit. So bringing a healthy amount of curiosity to the table. That's definitely important too. But I would look around for opportunities in your area and get your own VR headset if you can.
Okay, that sounds good. Do you have anything else you would like to add?
I'm very grateful that you gave me the opportunity to talk today. I usually talk, I give these academic talks where, you focus on, it's a very unilateral thing where you talk at an audience. And this was more like a dialogue, and I really appreciated that.
Yeah.
I'm also open if anybody wants to reach out, interested in research internships, or wants some pointers on like how to enter this kind of discipline. Happy to answer any questions.
Okay. Well then, that concludes another insightful episode of our podcast. A huge thank you to our incredible guest, Dr. Bueckle, for sharing his expertise and vision in the dynamic realms of AR and VR. If you found today's episode as fascinating as we did, don't forget to check out Dr. Bueckle's work at andreas-bueckle.com. Until next time, keep exploring, keep learning, and keep pushing the boundaries. This is Sal Ignat, signing off. Take care and stay curious.